LED lighting is expanding its influence in various areas. While farming methods change over time, LED is being considered the main source of lighting. Horticulture lighting requires extreme efficiency with excellent durability due to extended usage and harsh horticulture environments. We will introduce Samsung's unique lighting solution that is going to change the horticulture industry. According to the LED Inside 2019 report, the general LED lighting market is expected to grow at an annual growth rate of just 5%. However, the growth of the horticulture LED lighting market is more explosive and is expected to grow at a CAGR of 27% by 2022. It's a rapidly growing market with huge potential, and it's attracting a lot of attention from both industry and academia. The growth of the horticulture LED market is mainly driven by the following three reasons. First, the horticulture industry is undergoing a transition from conventional lighting, such as metal halide or high-pressure sodium, to more efficient LED lighting because of LED's excellent cost-saving capabilities. Second, people are demanding fresher, healthier, and organic food. Third, the legalization of medical and recreational cannabis is driving the horticulture industry to begin mass production. However, the penetration rate of LED is 10%, and traditional lightings like fluorescent, metal halide, and high-pressure sodium are still dominating the market. A conventional LED solution is a simple combination of blue and red LEDs, called a narrow spectrum. It has some advantages over traditional lighting in efficacy, heat management, lifetime, warm-up time, and fixture design flexibility. However, there is still room for improvement, especially in the areas of system cost, spectrum controllability, and visibility to the human eye. What we propose is a full-spectrum LED, which has become a recent industry trend as a more cost-effective, productive, and favorable solution. Full spectrum covers a wide range of wavelengths and cost-effectively promotes well-balanced plant growth. Since the full spectrum is based on cost-efficient white LEDs, it can dramatically bring down the initial lighting system and operating costs. Full spectrum covers a broad length of wavelengths and promotes balanced plant growth by improving various aspects such as photosynthesis, immunity, and nutrition. Under full spectrum LED, plant growth can be well balanced and overall crop quality improves. Unlike the narrow spectrum's purple light, white-based full spectrum light is like normal light, which is more comfortable to human eyes. It enables easier detection of diseases and creates a pleasant work environment. Three things must be taken into account when choosing horticulture lighting, and these key considerations are spectrum, efficacy, and reliability. Later, we will move on and explore each of them. Samsung's horticulture LED lineup is equipped to address those key considerations. It provides wide-spectrum options that cater to various purposes. Samsung's renowned top-class Efficacy enables more productive horticulture lighting while saving operating costs. Lastly, our product's robust durability allows for reliable operation. We offer a wide-spectrum selection ranging from 450 nanometer blue to 730 nanometer far red necessary for plant growth. A simulation tool is also available for free that you can use to design a target spectrum and performance with Samsung LEDs. The spectrum can change the way plants grow, so it's very important to design the correct spectrum. Here, we experimented on leafy greens using narrow and full spectrums. The conditions were strictly controlled and the experiment was repeated 3 times using different batches to ensure reproducibility. The results showed that 10% extra fresh weight was obtained with the full spectrum, and this indicates spectrum matters for plant growth. Also, the overall cell structures under full spectrum lighting look excellent based on a cross-section analysis of leaves. This proves that full spectrum can improve both the quantity and quality of plants over the conventional narrow spectrum. With our technology, plants can be engineered to have a certain color, taste, and better immunity by changing the spectrum. There's plenty of interesting research in progress regarding spectrum engineering. Horticulture lighting uses different figure of merits compared to general lighting, and it's important to keep PAR, PPF, and PPE in mind. PAR stands for photosynthetic active radiation. PAR is the wavelengths of light within the 400 to 700 nanometer range, which drives photosynthesis. ppF is photosynthetic photon flux, and it measures the total amount of PAR produced by a lighting system each second. Its unit is micromoles per second. PPE indicates photosynthetic photon efficacy, and it refers to how efficient a lighting system is at converting electrical energy into ppF. The unit used is micromoles per joule. Samsung provides industry-leading high-efficacy LEDs, making a high PPE lighting system for horticulture applications possible. We are committed to provide the best efficacy LEDs, and we will continue to develop more innovative technologies. Here, the importance of high-efficacy LEDs is highlighted. High-efficacy LEDs can be operated at a higher current but the same efficacy. In other words, we get more ppF out of a single LED with high-efficacy LEDs without losing PPE. As a result, the number of LEDs can be significantly reduced by using high-efficacy LEDs when we design lighting systems with targeted ppF and PPE. By rule of thumb, 10% lower efficacy means 2 times the number of LEDs, which is 100% more. So, it's not just the 10% efficacy gap, it can be a 100% gap in terms of the number of LEDs. Another important advantage of using high-efficacy LEDs is their energy-saving capability. Vertical and indoor farming institutions consume a particularly large amount of electrical energy, which can be dramatically reduced by using high-efficacy LEDs. However, we must also look at the possible downsides of LEDs. There are 2 main types of LED failure mode found in horticultural lighting. These are blackout and performance degradation over time. Blackout is often caused by wire-related failure inside the LED, and performance degradation is related to the material's degradation due to a chemical reaction. Poor wire bonding process control and frequent on-off switching of LEDs in the field can cause wire failure. To prevent this, Samsung utilizes flip-chip type LEDs as a solution, as they do not have wires at all. The LED flip-chip type exhibits better thermal dissipation during frequent on and off switching when compared to an epi-up design. As such, wire failure is reduced thanks to frequently minimized material expansion and contraction. LED performance degradation can be caused by chemical exposure. For example, LEDs can be damaged by sulfur in a horticulture environment. Sulfur is one of 6 essential nutrients and is commonly contained in chemical fertilizer. Sulfur is also used as an acidifier to lower the pH level of the soil and sometimes burned or vaporized for pest control and disinfection. If an LED is not designed properly, sulfur can react with the silver lead frame inside the LED and reduce its performance. The chemical reaction creates a dark material and causes discoloration as shown here. To prevent chemical reactions, LEDs with protection schemes are more desirable. An IP rating at the fixture level is not enough because ingress protection is against solids and liquids, not against gases. So, the LED itself needs to be sturdy. Covering the silver lead frame with a reflector structure or coating everything with a protection layer are some of the solutions we are using right now. When we compare horticultural LEDs and normal LEDs in sulfurization tests following the IEC standard, the horticulture LED shows much better performance maintenance. LEDs used for horticultural applications should be different from a normal LED in terms of reliability. The 2 major applications for horticultural LEDs are vertical farming and greenhouse farming. Typically suggested LED solutions for vertical farming are a combination of mid-power whites with high-power reds. Greenhouse farming benefits more from a combination of high-power white LEDs with high-power reds. Since the LED is the only light source in a vertical farming scenario, efficacy is a key factor due to the importance of cost savings. Lower installation and operating costs compared to retrofit conventional lighting solutions matter the most in greenhouse farming. Samsung's horticulture lighting technology will play a crucial role in the horticulture revolution. We will continue to pay attention to the market and develop solutions that innovate the horticulture industry. Thank you.